All right. Hi, everyone. This is NET-213. Okay, this was Friday's class, and we're finishing up the chapter on protocols. So I believe that's chapter 3. So we did some review at the beginning of the class. We talked about protocols in general. We talked about encapsulation. We talked about some things in terms of the size, timing, and then we reviewed this part right here. A unicast. A unicast is like how we connect to the internet. If we were to take a look at this PC is going to, let's say, this web server right here. We go out. We talked about this a lot today. Into the internet, jumps around some different routers, eventually ends up here, ends up at their ISP, here, somehow at their network, and then we end up there. And this could be, different routers out on the internet. Okay, and then the web server responds, it sends something back, and it doesn't have to go the exact same way until it gets here, and then it comes down here. It's a unicast. We send something to them, they send something back. It is possible to do some things that are multicast, okay, one to many instead of one to one. And the multicast we'll do in red. Let's say this web server is going to serve up some video. It might send a packet of that video, and maybe some of the videos going to NIACC, and maybe some of the videos going to another school here, and maybe another one here. And so that packet leaves, it works, that one packet works through the internet, and then maybe it splits there. A multicast. Just these three are going to be involved with it, and it's really different than a broadcast. Okay, we don't broadcast things through the internet. Okay, so the packets representing the video don't have to get split up until they get to where they need to go. Alright, then a broadcast is which, for example, when we talked about today, when this PC needs to go to a particular address. Let's say, an example today, we pinged a server, and so we have up here another switch, and then we have a server up here. So I sent a request to that server's IP. I had the IP address of that server. Well, before I send it, our computer, we talked about this, it's actually written over here, did an address resolution, used address resolution protocol, sent a broadcast. The broadcast then, let's say the broadcast now is in, I'll pick some crazy color here, let's say green for now. So the broadcast then went everywhere, because it was trying to find, the ARP is trying to find the MAC address, and so it went to all the computers in 217, 216, and eventually it got to this baby right here. And then it set back its MAC address to me, to the computer I was using, and now I can do a unicast to that address. So that's a broadcast. Alright. And then there's a couple of student questions here. We talked a little bit about excuse me, a little bit about our address internally going to an external, if you're curious, so how we do network address translation at our router before it goes out. This is that 207.165.226.97 address that's used out on the internet. Got it from our ISP, and the college then gave a certain group of those to our side of the network, and this would be an address of one of the students' local computer. And we get the translation. And we learn more about that later on. Okay. We talked about layers. And we talked about application layer, and then in the curriculum they give lots of examples like DNS, DHCP, maybe things dealing with email like IMAP, simple mail transfer protocol, POP. We talked about HTTP for the internet. We talked about transferring files. We have file transfer protocol and trivial file transfer protocol. File transfer protocol uses TCP and verifies. Trivial uses UDP and does not verify. Best effort, and this would verify. Most of our communications with just unicast to websites are TCP. Some things like running that video through the internet that I talked about before, that would be UDP. Okay? So, we have application protocols, then we have to figure out how to transport. So we have transport protocols, we talked about those in class. Then we talked about some internet protocols, ICMP, I like to do a ping, network address translation. We have a whole group of routing protocols. We'll learn about those later. And then we have network address. We talked about the physical address and our connection to the network. And again, you hear me talk about all the time, the medium, how are we connected in. Okay, over here in where we're listing these routers, I did an example here, talked about an example of connecting in. For example, multicast would come maybe to this router and then get distributed to this router and then get distributed. Alright, I'm going to go to the last page. We did a lot of examples in class. Okay, if I go back to the page, so here's that web server. Eventually it gets that to the internet, and it moves through the internet, through different routers, and it comes out the ISP. It's going to go to our computer, Wireshark, and so forth. And so here are the layered idea that we talked about. And then what we did was we talked about this OSI model. It's a model. It's a model to help us understand how information is sent. So, excuse me. So what we did for an example is we said we're getting some information back from a web server. We've already sent them a request and they're going to send it back. So there's some web server, and we use Apache web server as an example. It could be other IIS or whatever. So they're hooked into the app. Okay? Sometimes people even use that exact comment, hooked into the app. Then the data is presented, like if it's a secured site, let's say if it was an HTTPS, a secured site, we could encrypt the data get encrypted, or if the data, if we're doing an FTP, it can be compressed, possibly. So we present the data. So we have an application layer, presentation, then we create a session. Okay, and the session's not going to end if we're using TCP. It's not going to end until we have all of the information. And we looked a little bit at that at Wireshark. So the browser has the HTML. It's hooked into the application layer. The data is presented. Then we create a session. Then we figure out how we're going to transport the data. Okay, how we're going to transport the data. That would correspond to one of these two right now. Now, it gets a little more involved, but for just getting started with networking, we're either going to do transmission control protocol, okay, in which we're going to transport that data and verify. Okay, we're going to verify. Or we have user datagram, in which we're going to take and just send the data. And we looked at that with Wireshark. We looked at comparisons. Figure out how to transport it. So in terms and technology, we'll refer to, we segment the data, we put it in parts, and we can give those port numbers. Then we're going to take each one of those parts and we'll create a packet out of it. We're going to determine the best path to send it through the network. And this is where we get into what we talk about IP. In fact, over here they called it the Internet Protocol. We go IP. So we're going to put an IP address on it, so it's packet. So now we have a piece of data, we have some port numbers, now we're going to put an IP, and all this adding of information is called encapsulation. Okay? Maybe put a little information here at the end. So now we have an IP, a destination IP address in there, we have the source, and so forth. And then it's often called a packet. We come to the data link. Okay, come to the data link, and we have this web server, and it needs to put the information, let's say, to a switch. Got a hard drive, and we have all this stuff on the computer, and we need to put it into a switch. Okay, so 802.3, use a MAC address. If this is Ethernet, to connect it there, we create what's known as a frame. So out here we encapsulate this data even more. Somewhere we have a destination MAC and the source MAC, which computer it came from, which computer it's going to. Now in this case you say, well, there's no way we know the MAC address of the computer way on the other end, so it will just connect to its default gateway. So it'll put the MAC address of the default gateway, and then this router, who doesn't know who we are either, it'll just keep defaulting until it gets out to the internet. Okay, so if I was so it's going to go to our computer here, and then it's going to come in. Okay, when it gets to our computer, it's going to go through the switches. It's going to come out of the switch. So then here sits the switch at NIACC. This has gone through the internet and comes back. Hits our router figures out which part of the network to send it to, comes to the switch, and then the switch is going to send it to our PC. So it comes into the PC, the bits, and we have the data link, so it checks to make sure the MAC addresses match, and so that it takes that information off. In fact, let me use that color here, so it's going to take that off. Okay, I suppose I could use the eraser. Let's see if that works. So it's going to take this information off. Okay, then it's going to check the IP address. Okay, if that looks good, then it can take that information off. Then it gets up to the session layer. Make sure that the session, it keeps track of the session with TCP, and that looks good. If the data was encrypted, it's going to decrypt it here, move it up to the app. Our browser then will read the data and create the page inside our browser. All right, so that's an overview of what we talked about in terms of the notes. We will actually review Chapter 3 a little bit on the next session and move right into Chapter 4. So that's it.